Okay, here's warm-up 8.5. I'm going to write a rule for this sequence. So first I need to figure out if this is arithmetic or geometric. So I'm thinking, am I adding the same thing to get from term to term or multiplying by the same thing? In this case, it's going to be multiplication because we can multiply by -2 and go from term to term all the way down the line there, right? So I know then that this is going to be geometric. Okay, and that determines which formula I'm going to use for, I call this the specific term formula. It's going to look like this. Okay, and writing a rule is just plugging the pieces into this and simplifying it a little bit. Okay, so I'm going to leave this as a sub n. A sub 1 is my first term, so that's going to be 4. Okay, and then the ratio is what I'm multiplying by to get from term to term, so that's -2. And then I leave it like so. Okay. Now, a common mistake that I see is people sometimes try to simplify this into, they'll do the multiplication here and say, okay, then it's -8 to the n minus 1. Or like that. But that's not the case because you have to do the exponent before the multiplication, and the exponent for the 4 is actually a 1. So you can't do anything else with this. I don't really need the 4 in parentheses. I'm not sure why I did that. But you can't simplify this any further. So that's our rule. Not this, right? Okay. All right, so now we can use that to find any term. So we're asked to find the 21st term. So rather than building the whole formula out to the 21st term, I can just use this formula and plug in 21 for n. Okay, and then start simplifying. Okay, and then again, don't do the multiplication before you do the exponent. And I don't know what -2 to the 20th is, so I'm going to need my calculator. I'm going to put the -2 in parentheses just to make sure that my calculator doesn't take 2 and raise it to the 20th and then take the opposite of that. That's what my calculator would do. Okay, so I've got this rather large number here. And then I'll multiply that by 4. Okay, so I've got 4,194,304. Okay. Just a little side note on that last problem. So if you didn't put the -2 in parentheses like I did, well, that's in parentheses. If you don't put it in parentheses, then your calculator will do the exponent first, then multiply by -1, and you'll get a different result, right? So it's really important when you're raising negative numbers to an exponent on a calculator that you use parentheses. Okay? All right, so now we want the sum formula for geometric sequences, or series actually, and that's going to look like this. It's going to be the first term, and then I've got a big fraction, 1 minus r to the n over 1 minus r. So this is going to be my first term, right? So here I'm looking for the sum of the first 21 terms. The first term, I can see the first term is 4. Okay, and then the ratio is -2, so that's going to go in both of those slots. Okay, and then 21 is n, so this is my setup, okay? So it's okay in the denominator to simplify that to 1 plus 2. It would be 1 plus 2, which is 3, okay? But you can't do that in the numerator because, again, this is raised to an exponent. So you have to do the exponent before the subtraction. So you can't simplify that to 3 to the 21st. It's not equivalent to that, okay? So, whoops, it should be a -2 there. Okay, so I'm starting here, okay? I'm going to use my calculator for this. I'm going to start with this exponent first. Okay, so I've got a -2 in parentheses again. I'm raising that to the 21st. Whoops, I raised it to the 20th. Okay, so there it's raised to the 21st, okay? then I'm going to do 1 minus that, and I can retype that whole number if I want to, but I like to use the, if you hit second and then this negative button down there, then it's just going to use that whole last answer. So 1 minus my last answer. Okay, so this would be the numerator, right? So here, let's go ahead and write that in. Okay, so next I'll be dividing by 3. Okay, and then the last step would be to multiply by 4. And let's see, 2796204. So, okay, 2,796,204. Okay. All right. So again, we've got a geometric series here that we're evaluating. So that means we're finding the sum of this series. This time we have sigma notation though, but I'm still going to use this same formula from the last problem. I'm just rewriting the formula here so I have it to reference. Okay, so I need to first figure out how many terms I'm dealing with. Okay, and I'm going to be dealing with 18 terms because I'm going to be plugging everything from 1 to 18 into this formula to build the terms. So I've got 18 total terms. Okay, now I need the first term. I can just build the first term. That's totally fine. So my first term I'm going to build by plugging in 1 for k. Okay, and then I'm going to have, here, I'm going to have to do this up here because I'm going to be short on space. That's going to be 2 times 4 to the 0th. Well, 4 to the 0th equals 1. So I've got 2 times 1. So that first term then is going to be 2. Okay. Also, when you've got an sigma notation in this format, where you have, sorry, I'm focusing my camera there, where you have k minus 1 as your exponent, then this is going to end up being the first term. But you can only use that if, first off, if it's starting with plugging in 1 at the bottom of the sigma notation, but also if you have k minus 1 as your exponent. Okay, so it's a little shortcut. That's going to be a sub 1, and that's what happened. Okay, now the ratio, let's build a second term so that I can find the ratio. The second term, I would plug in 2 for k. Okay, and this is going to go on, but I only need these first 2 terms here. So let's see, I'm going to have 2 times 4 to the first. Well, 4 to the first is just 4, so 2 times 4 is going to be 8. Okay, so here, let me zoom out a little bit. So my first term was 2, and my second term was 8, and now I can find the ratio between those. It's going to be 4, right? We'd be multiplying by 4. And hey, there's another shortcut. When you're in this format, again, this is going to be the ratio. So if you know where to look, you don't actually have to build the terms out if you've got sigma notation in this format. Okay, so ratio is going to be 4 then. And n is 18. Okay, and so I'm going to do the rest of this on my calculator. I'm going to start with that 4 to the 18th. Okay, and I'm running short on space here. So let's see, 4 to the 18th. It's a pretty large number. Notice I've got the E10 thing. That means this is in scientific notation. This is times 10 to the 10th. So that means that this decimal is actually moved 10 spots to the right from here. Okay, so I'm going to do 1 minus that, and I'm not going to round this as I go. I want to keep these decimals, nice long decimals, in my calculator. So I'm using the last answer thing. That makes it much easier, especially in scientific notation. So this is going to be my numerator. Okay. The denominator, I can see that the denominator is going to be -3, right? So I'm going to just divide this by -3. Okay, and then the last piece would be to multiply by 2. Okay, and I've still got a number in scientific notation. So I am going to have to round this at this point, but I didn't round as I go, because if you do that, it'll throw your answer off. The more you round as you go, the worse your answer will be. Okay, so I'm going to go 2 places past the decimal. I'll call this about 4.58 times 10 to the 10th. That's a really large number, right? Again, the decimal's moved 10 spots to the right from there. Okay. All right. These next two geometric series are infinite geometric series because we're starting with a 1, but then we're using all the integers till we get to infinity, which we'll never get to, right? So it's a never-ending series. So I could start building it, but I would be here for till the end of all time and past if I tried to build out the whole series. Okay, so there's a formula for geometric infinite series, and it's going to look like, oh, sorry, I shouldn't say n there. I should say, put the little infinity symbol. It's going to look like this. It's going to be a sub 1 over 1 minus r, okay? So if we use that little shortcut from the last problem, because this is in the same format, hey, this would be my first term, and this is going to be the ratio. So then I've got the pieces I need to plug in, okay? You also need to check, though, that the ratio has to be between 1 and -1 on the number line. So 0.3 is between that. If it's not, you can't actually find the infinite geometric sum, but here we can. So this does qualify. Okay, so I plugged in the 7 and the 0.3, and I've got 7 over, this would be 0.7, okay? So you probably don't need a calculator for that, but if you plug it into a calculator, it's going to be 10. Okay, and a nice way to check these is you could build a couple of terms, and you should, as you add up the terms, it should be approaching 10 really quickly. So in no time flat, you should be around 9.9 and getting closer and closer. You'll never actually get to 10 itself, but that's what we're approaching, so that is the infinite sum then, okay? So it's the same formula down here, but heads up, our ratio is going to be 5, okay? So if the first term that's my first term, right? It's going to be 2.3. If I'm going to multiply that by 5 to get the next term, so let's see, 2.3 times 5, then I'm going to get 11.5 for my next term, times 2.3, and then I'm going to get 26.45 for the term after that. Okay, and it's going to go on like that, but these jumps are getting bigger and bigger. So you can see the difference between 2 and 11 is smaller than the difference between 11 and 26. So this isn't going to work, okay? So you'd have to say that your infinite sum is either infinity, or you could say no sum, since infinity isn't a real number, or no solution, or something along those lines, or doesn't exist. Okay, well, yeah, or infinity, no solution, doesn't exist, something along those lines. Okay? All right, and that's it for this warm-up, and I'll see you next